Good day. Today we're going to take a look at the TX16S Next Level Gimbals by RadioMaster. These are premium quality CNC milled aluminum Hall sensor gimbals designed for precision control and flight performance. I'll describe and demonstrate some of the features and benefits of these RadioMaster AG01 gimbals over the stock gimbals that came with my RadioMaster TX16S Max transmitter, show you how quick and easy it is to install them into your TX16S, then take the AG01 CNC aluminum Hall sensor gimbals out for a quick test flight to give you my thoughts on how they perform. These gimbals come in a nice package with extra lubricant for use on the bearings and other moving parts, and also damping oil for use under the throttle tension bar to keep that smooth feeling with your throttle stick. The gimbals themselves already come with the lubricant and the damping oil applied, so you don't need to do this initially yourself. The lubricating and the damping oil are also sold separately as a set when you need more. It's available through a link in this video's description below for your convenience as usual, along with any other resources and products mentioned in this video. You get an instruction sheet and also a set of weaker springs that come with 17 coil turns instead of the 14 coil turns on the already installed springs. So if you want less spring tension than you have with the factory installed springs, you can use these weaker springs. However, before you go through the process of replacing the springs, these gimbals have adjustable spring tension. I'd encourage you to try first, and I'll demonstrate that here shortly. Now, if you do decide to replace the springs, one way to do it more easily is to completely loosen the adjustment tension screw associated with the spring. Let's say you wanted to change out the tension spring for the vertical axis or your pitch axis, which would be this one right here. An easier way to do that, as opposed to trying to pry these ends off as is to go ahead and completely loosen the adjustment screw, which you see here protruding from the back of the gimbal. That screw is what you turn here. This is the vertical or up and down spring tension screw as identified by 3 in the instruction sheet. So the first thing you do is go ahead and loosen that completely so that the end of the screw comes completely out of this housing here. We'll go ahead and do that. And now you can see the adjustment screw is completely out of this housing. The next thing you want to do is take this screw off. And it's got a washer on there, so you want to be careful with it. Don't lose your adjustment screw. And there's the washer and the screw that comes out. Now this piece right here should just slide right out the top, like that. And then you've got this spring completely loose, which you can just take off of here. Like that, and replace it with the weaker spring. And then just go ahead and attach it back and reverse the entire process. And you've replaced your spring. It's that simple. I myself don't like the weaker springs, so I'm going to put the original one back on. Now let's take a look at the features on these AG01 gimbals. They're constructed of CNC processed aluminum for precise tolerances and also durability. Metal, 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 and metal. They're also designed with quad bearings, which you can see here, and also here you can see 2 of the 4 that way. And these are for use on both the horizontal and the vertical axes, which gives your sticks a continuous, uninterrupted travel flow feeling. The throttle friction and ratchet bars are adjusted at the back of the gimbal as usual, with this one inside being your throttle friction and this one outside being your ratchet. And you can see the difference perhaps on the wheels associated with each, where this outside wheel has got some teeth to it. So before I install the gimbal, I'm going to check out the amount of friction it has to ensure it's what I want. I want the throttle stick to be able to maintain its last position when I let go of it. Not like that. I don't want it to have too much more friction than that, but that's my own personal preference. To increase the throttle tension, simply turn the tension screw clockwise or to the right, and to loosen the tension, turn it counterclockwise or to the left. If you'd like to increase the ratcheting effect on your throttle, the ratchet tension screw works in exactly the same way. Simply increase the ratchet effect by turning the tension screw to the right, and decrease or eliminate the ratchet effect by turning it to the left. I'm going to leave my ratchet effect off, but I do want to increase the throttle tension so it maintains its position when I let go of the throttle. So let's go ahead and do that with the supplied Allen wrench and tighten this down by turning it to the right until I'm able to let go of the throttle and have it keep its position. That should be good for now. Now that we have our throttle tension set the way we want it, we can go ahead and install our gimbals. Both gimbals are identical, except for the fact that one comes preset as the throttle, with the spring disengaged on the throttle axis, whereas the other one comes preset stick centering. We can engage, disengage, and change the tension on any of the springs through adjustment screws on the front of the gimbals. And I'll demonstrate that after we've installed them. When you install the gimbals, you just want to make sure that the wiring harnesses on each is to the outside edge of the transmitter. So if this is our throttle gimbal, which it is, and we've got the back of the transmitter opened up, we would want the wiring harness for the throttle to the outside edge of the transmitter, and our right gimbal, when looking at it from the front of the transmitter, installed like this, with the wiring harness to this edge of the transmitter. These AG01 gimbals are really simple to install in your transmitter. First, remove your TBS Crossfire or Express LRS module from the back of the transmitter. Then remove your battery from your battery compartment. To remove the back of your transmitter, you simply pull these side grips off. They just snap on. Then you have 4 screws on the back which you'll need to remove, and 2 hex screws at the top holding the antenna plate in. So 6 screws in total. Be gentle with that because it's got the antenna cable running through it. Once those 6 screws are removed, gently pull the back of the transmitter apart. You'll notice you may have speaker cables attached, which you can disconnect if you'd like to. Before I disconnect anything, I like to take a picture of how it's installed so I can refer back to the picture for reinstallation if necessary. We now have access to remove and replace our original gimbals. I'll demonstrate how to do it with one, since the other one is exactly the same, and I don't want to waste your time. So I'll remove and replace my throttle gimbal, which is this one, since I fly in mode 2. First, disconnect the cable from the main board that goes to your gimbal. It runs underneath this wiring harness here, like that. Then each gimbal has 4 screws, which you need to remove, 1 in each corner. There's 1 down here. So just remove those and gently pull your gimbal out. If I can get this one. Like that. Now when we remove this, there's a couple things to notice. First of all, the faceplate came out with it. Since our new AG01 CNC milled Hall gimbal comes with its own faceplate, we need to remove this from each gimbal in the TX16S. So we're not going to be using the faceplates. Secondly, the bezel remained inside the gimbal slot. Now you can take this out or leave it in. If you leave it in, your gimbal may be recessed a little bit more down into the transmitter, making your stick height a bit shorter. However, that too is adjustable, which I'll demonstrate in just a bit. In my case, I'm going to remove this bezel because you don't need it. It just pops right out like that for two reasons. One, this faceplate looks nice the way it is in the TX16S. And two, it seems to fit just a little bit better without the bezel into the gimbal socket with the original screws replaced into their screw holes. Now, because you don't have that thickness of the bezel for this to ride on top of, you want to be careful when you screw the original screws back in so that you don't strip out the screw holes, because they will tend to go in a little bit deeper. So screw them back in gently. All we need to do now is insert the new AG01 aluminum gimbal into position. Wires out of the way. And it just slides into place. Like that. Reinstall the 4 screws and reconnect the gimbal wire harness underneath this wiring harness the way it was originally. Like that. That's it. Do the same for the other gimbal. Reconnect your speaker if you've disconnected that. Reinstall the back plate of the transmitter, the antenna plate, and the side grips, which just snap back on. You're done. All right, now we can adjust both gimbals' spring tensions on the vertical and horizontal axes using the tension screws for each. I'll demonstrate it on the left gimbal. If we look at the instruction sheet, the vertical spring tension, or the up and down spring tension, is this adjustment screw up here at the top. We turn the screws clockwise or to the right to increase the spring's tension, and counterclockwise or to the left to decrease the spring's tension. Just do this for your own personal preference. You can also limit the amount of vertical axis stick travel, for instance on your throttle stick, by adjusting the upper and lower limits using these two adjustment screws. You turn the screws clockwise to reduce the stick travel, or counterclockwise to increase it. Let me go ahead and demonstrate. Right now, it's at max stick travel. So if I turn these clockwise to reduce it, this is actually the upper limit. And you can see now it doesn't go all the way to the top of the gimbal. Turn the lower limit adjustment screw clockwise. Right now you see it goes down that far. And as I turn this, you should see the stick move up, which it is. The available travel stick range is from 38 to 54 degrees. I myself prefer maximum range because that gives me the most throttle resolution. And that just means I can move my throttle more to produce slight changes in velocity or altitude than if I limited my throttle stick travel. So I'm going to change this back to maximum stick travel. The horizontal spring tension is this adjustment screw right here actually sitting on the gimbal. So if we want to reduce the spring tension on the horizontal, or in this case our yaw axis, we go ahead and turn this counterclockwise as we mentioned earlier until we get it to the desired spring tension that we want. That's obviously much too loose for what I prefer, since it's not even going back to center. So we'll tighten this back up to where it was. Another adjustment you're able to make is changing transmitter modes from mode 2 with the throttle on the left stick to mode 1 with the throttle on the right stick, instead of self-centering. To do this, you simply turn the mode adjustment screw on the left gimbal counterclockwise, which is located here on the left gimbal, and turn the mode adjustment screw on the right gimbal clockwise all the way, which is located here. Let's go ahead and do that. You may have just saw the left stick is starting to self-center. So now the left stick self-centers, and the right stick, we take the mode adjustment screw and turn that all the way clockwise, and it should go from self-centering to non-self-centering and make it our throttle stick, going from mode 2 with throttle on the left to mode 1 with throttle on the right. And you see the stick is already starting to not self-center. There. Now you switch from mode 2 to mode 1. That's not how I fly, so I'm going to switch them back. The last adjustment you can do is what I mentioned previously when talking about leaving the red bevels in place. You can adjust your stick height. To do that, unscrew the top of the stick. Then there's this piece underneath right here. You can rotate to increase its height towards the top. And we rotate that to the left or counterclockwise, and it'll increase its height. And once you have that in the correct position for you, simply tighten down the top of the stick so it rests on top of the part underneath it, like this. It's that simple. You can do the same with your other stick. Personal preference. Before we do anything else, we need to calibrate our new AG01 TX16S CNC gimbals. We go to our system menu, page over to Calibrate, right there, press enter, and we're doing this at room temperature, which right now is 77 degrees Fahrenheit, and we're going to center our stick spot sliders and press enter. Our 6 position switch up here, we're going to put on 4 pots. And now we press enter. And then we're going to move the stick spots and sliders and press enter. We're going to move them to their extreme positions, but we're not going to jam them up there. We're just going to gently press them against the max positions. Here, here, here. Same with the right stick. Pots, sliders. And we also want to do the 6 position switch up at the top. We'll start in 1 and we'll put it back at 4. And now that we're done, we're going to go ahead and press enter. Now let's check our first 4 transmitter channels to see if we observe any jitter. I've got to change the throttle limit to max. And here you see channels 1 through 4, I'm not getting any jitter, which is great. Now I've heard some folks say that with the original TX16S gimbals, they've had what's referred to as temperature drift. Hall sensor's electrical sensitivity can change depending upon the temperature extreme. So for instance, if you calibrate your gimbals at one temperature, such as room temperature, and then go fly with them at a much colder or hotter temperature, their calibration could be off slightly. RadioMaster has informed me that there have been some improvements to the Hall sensor circuit on the AG01 gimbals over that of the original gimbals. I'm not sure what those specific improvements have been. However, I did notice the PCB on the AG01 gimbals Hall sensor circuit is thicker than the original gimbal PCB here. And the PCB thickness can have an effect on its conductivity and resistance. I've also noticed the stencil on the new PCB shows RadioMaster TX16S Mag V2.3, whereas this original PCB didn't have a stencil at all. I'm not sure if the mag in the AG01 Hall sensor circuit stencil is referring to a different type of magnet, something else, or if it's an entirely new chip. However, I'm going to conduct a non-scientific test to see if I notice any temperature drift with our new AG01 TX16S gimbals. I'm going to put the transmitter in the refrigerator for about 30 minutes, then pull it out and check our channels again for any jitter. I'll then compare those results with the results with the same type of non-scientific test of the original gimbals. Alright, after calibrating at room temperature and then placing the transmitter in the fridge for about 30 minutes, let's see if the 4 control channels on our AG01 CNC Hall gimbals are experiencing any noticeable drift and compare them with the original gimbals shown on the left, which have gone through the same refrigeration process. Absolutely zero. None. Outstanding. Good stuff. Now it's time for a quick test flight to see how they perform. It's fly time.
So, what do I think about these AG01 CNC Hall gimbals? Honestly, they're simply the best gimbals I've ever flown, and I've flown 8 different transmitters and about 11 different sets of gimbals. Do I notice a big difference between these and the original Hall gimbals? Yes, absolutely, without a doubt. In short, they feel good. That's going to do it for today. Hope you found this informative and useful. Remember to subscribe for more fun FPV stuff. Thanks for your time, and I'll catch you next video. Clear skies, friend.